All right, we are going to look at the Algebra 1 final review and kind of work through some of these questions and hopefully clear up some of the questions that you might have about some of these. So we start off with solving an equation, quite a few parts, but only one side has a variable. So the first thing we're going to do is combine like terms. So I've got 8x and negative 6x. I'm going to combine those to 2x and then plus 3. On the right side, we're going to do our negative 7 plus 20 and just do the arithmetic there to get 13. So now we've got just a single variable on the left side, which means we can leave that. Let's subtract 3 from the left side and then in turn subtract 3 from the right side to get that x term by itself. That cancels. So we're at 2x. 13 minus 3 is 10. Last step is to divide by 2, and to divide by 2, and we would get x is equal to 5. And remember, anytime you're questioning yourself here, you can check this by saying 8 times 5 plus 3 minus 6 times 5 should have equaled negative 7 plus 20. If you go ahead and do that math, everything should check out. 8 times 5 is 40, plus 3 minus 30 should equal 13. 40 plus 3 is 43. 43 minus 30 is 13. So we know we're good. Second question, similar, except we've got distributive property to happen first. So I'm going to distribute that 3 through the parentheses to get 6x minus 15. And then I'm going to rewrite everything. Then we can do what we did up above and combine like terms. I've got 2x terms and 2 numbers on the left side. So 6x minus 4x is 2x. Negative 15 plus 8 is negative 7. And on the right side, there's nothing to combine because I have a number and a letter. Once we've combined like terms and distributed, now we can solve this thing. For x, I always like to keep the x's positive, so I'm going to subtract 2x from the left side, and then in turn subtract 2x from the right side, so I've got negative 7 equals negative 1 plus 3x. I've got the x on the right side, so I'm going to move my number from the right side to the left side. Negative 7 plus 1 is negative 6. And that's equal to 3x. We'll divide by the coefficient of x, which is 3. And we get x is equal to negative 2. And just like we did up in that previous problem, if we wanted to come up here and change our x to negative 2, change our x to negative 2, and change our x to negative 2, we should get the left side to equal the right side. All right, solve and graph the compound inequality. So we've got an OR, so basically we're going to solve each of these individually. So I'm going to solve that left one first. I've got, just going to subtract 3 from both sides. I've got x greater than or equal to negative 2. And then I'm going to do that on the right side. And I'm going to add 5 to both sides. 8x less than or equal to 8. This one I've got to divide by 8. I get x and 1. And because we divided by a positive number, not a negative number, our inequality sign does not change directions. So I've got negative 2 and 1. Let me put some numbers down here on my number line. All right, I've got x is greater than or equal to negative 2. So that is going to be an arrow going that direction. I've got x is less than or equal to 1. Closed circle. Oops, I should have changed these colors, but less than is going to go that direction. So because it's an or and because we've got arrows going both directions, we end up with all real numbers for our solutions because this is an or. So anything that is headed this direction works, as does everything headed that direction. Now, if this was an and, it would just be this little chunk here. But because it's an or, we can take anything that goes to the right of our first answer or anything that goes to the left of our second answer. All right, so solve the absolute value inequality, or absolute value equation, I'm sorry. Absolute value equations, if you remember, what we do is once we get the absolute value brackets by themselves, sometimes you got to add or subtract some stuff or divide before we do this first step. But once I get to the absolute value brackets, again, if you've got other things around here, like a +2, you would subtract it. Or if you had a 3 out here, you would divide. But again, once you've got just the brackets themselves, then we solve this as 2x minus 5 equals 9. We also will solve 2x minus 5 equals -9. So we're just going to solve both these. We're going to go +5 plus 5. 2x equals 14. Divide by 2, divide by 2. And x equals 7. We're going to do that over here. +5 plus 5. 2x equals -4. Divide by 2, divide by 2. X equals -2. And we've got two different answers there. X could be 7. So 2 times 7 minus 5. The absolute value of that would equal 9. Because 2 times 7 is 14. 14 minus 5 is 9. And the absolute value of 9 equals 9. And 2 times -2 minus 5 equals -4 minus 5, which equals -9. But since we're dealing in absolute value, the absolute value of -9 is still 9. All right, here we're going to graph. Remember, this is our y-intercept. This is our slope. Our slope is negative, so we're expecting a line that's going to do that. I'm going to start with my y-intercept. I'm going to put a dot at 1. And that's all I need for that piece. Now I'm going to do the slope of -2. Again, it's down 2 values over 1, not necessarily 2 boxes, but down 2 values, 1, 2, over 1, down 2, over 1, or up 2, over 1. Again, all while following that negative slope direction. So I've got my dots, I've got a couple more. I can connect those, and there's my line. Number 6, I can write an equation in point slope or slope intercept form that passes through the given points. Both of these, if you notice in the word, I've got the word slope, so I do need to find the slope of this thing first. So I'm going to do my y2 minus y1 over x2 minus x1 to find the slope. So I'm going to go 6 minus 4 over 3 minus 2. 6 minus 4 is 2. 3 minus 2 is 1. 2 over 1 is equal to 2. So that's my slope, or my m value. Now, if I'm going to go to point slope, that's the easy one, because I'm just going to do y minus y1 equals m times x minus x1. I know my m value is 2. And then we just put in, again, one of those 2 points. Doesn't matter which one's which, but I've got an xy value in both of those. So this would be my x1 value. So I'm going to go y minus 2, or x minus 2, sorry. And on my y, which is the 4, I'd go y minus 4. I could have done that with the other one. I would have done y minus 6, because the y value was 6, equals 2x minus 3, because the x value is 3. Those are the exact same answers, just using different points. If I'm going to go to slope-intercept form, I could have used my y equals mx plus b equation. And again, I know my slope is 2. So y equals 2x plus b. I need to find the y-intercept, so that would mean I would take one of my two values. Let's go 3, 6. Sub in the 6 for y. Sub in the 3 for x. And then what's left is my b value, so I would do 2 times 3, which is 6. 6 plus something has to equal 6. Obviously, we know that 6 plus 0 equals 6. So my b value is 0. That's a b, not a 6. So we would say it's y equals 2x plus 0, or y equals 2x. Plot the intercepts to graph the equation. 6y minus, or 6x minus 8y equals 24. Again, what I need here is the y value when x is 0 and the x value when y is 0. So we're going to do 6 times 0 minus 8y equals 24. 6 times 0 is 0. Minus 8y equals 24. Divide by negative 8, divide by negative 8, and y is equal to negative 3. So there's 1. When x is 0, y is negative 3. The other one, 6x minus 8. Now this time we're going to get the y be 0. So 6x equals 24. Divide by 6. X is equal to 4. So there's our other one. X equals 4, y equals 0. There's our 2 points. 4, 0. 0, negative 3. We also have the slope now of up 3 over 4. So if I want to plot some more points, up 3 over 4. Down 3 over 4. We got a line that looks something like that. Write the equation in standard form using integers. I really want to get that x and y on the same side, so I'm going to subtract 2x and subtract 2x, which leaves me negative 2x plus y equals 3. Would be one way to do it. Another way to do it would be to have moved the y over, which would then give us 0 equals 2x plus 3 minus y. I don't want this number here, so I'm going to subtract a 3 and subtract a 3, which then leaves us negative 3 equals 2x minus y. Again, either of those two would work. Obviously, the first way was a little bit easier. Are the graphs parallel, perpendicular, or neither? We got to know the slopes for both. So right now we don't know the slope of either of these. This one we're going to go plus 7x plus 7x. Y equals 7x plus 3. So now we know the slope is 7. So we are looking for a slope of 7 for parallel, or a slope of negative 1/7 if it was perpendicular. So this one I'm going to subtract 14x. I've got negative 2y equals 28 minus 14x. I'll divide by negative 2. Y equals negative 14 plus 7x. So, again, if we look at our slopes, I've got a 7 and a 7. They're both in y equals form. So if the slopes were the same, they're parallel, which they are. If they were perpendicular, we would be seeing a 7 and negative 1/7. Again, opposite signs and reciprocals. 7 over 1 becomes 1 over 7. All right, so that's about the first third. We'll see another video as we continue to work through this.